Can you trust Gen AI? Here's how you can handle and prevent hallucinations. In this video, we're going to cover 1, what are hallucinations? 2, what causes hallucinations in generative AI? And 3, the different solutions or ways that you can handle and prevent hallucinations to ultimately increase accuracy. So number 1, what are hallucinations? Well, in lay terms, effectively, hallucinations are when a generative AI model, quote, makes stuff up, or potentially says things that are factually inaccurate, oftentimes with a very high level of confidence. So let's go through 2 examples of hallucinations. And I would say hallucinations can kind of broadly fall in perhaps 2 buckets of ways of types of hallucinations. Some are more obvious than others. And I'll illustrate this with these 2 examples. So 1, let's say you decided to ask your large language model, what are the trial IDs for Ozempic, as an example. And this LLM ends up returning to you a couple of NCT IDs. And then you go to clinicaltrials.gov only to discover that the NCT ID doesn't even exist. So that is an example of a hallucination where the large language model generated the wrong trial ID, and those types of hallucinations are quite easy, black and white, to verify. The second kind of bucket of hallucinations is not always so obvious in terms of determining the level of accuracy, because the level of accuracy needs to be defined by ultimately what you consider to be accurate. So here's an example. Let's say we ask the question of an LLM, what causes diabetes? So let's say for this hypothetical example, the ideal, quote, accurate answer is a broad lay summary versus a very technical medical summary. So let's say in this case, the ideal accurate answer is that diabetes can be caused by a variety of environmental and genetic factors, including obesity, lack of physical exercise, and poor diet. So let's say we can generally say that that statement is fairly true, even though it might not be technically medical, so to speak. But let's say instead what the LLM did is it returned what we would consider a hallucinatory response in this case, which could be diabetes is caused by an increased intake in sugar. And if you reduce the amount of your sugar intake, it'll cure diabetes. So obviously that hallucinatory answer is definitively wrong. But the nuance and the difference is that that accurate ideal answer can also be subjective, right? So it's kind of up to you to define what accuracy and an ideal answer is to a specific set of queries. So 2, let's move on to what causes hallucinations when it comes to generative AI models. So on a high level, what we need to understand is that large language models or generative AI models are not knowledge models, and they're not fact learning models. They are language models. And what they do is they statistically correlate what tokens, another way to look at it is kind of what words are statistically correlated to go together with each other, and how those tokens or words themselves correlate to your input question. So in the example of diabetes, likely that large language model, when it was trained on volumes of text, saw that when the word diabetes was mentioned, it also typically was mentioned alongside sugar intake. So because the language model made that correlation, it now, in the response, decided that based on your question, it should generate a piece of text that has those 2 words in it. And therefore, this is why it, quote, hallucinated in that case. And this nuance is really important to understand, because large language models, when they are trained, they are not looking at text and doing logical reasoning on that text. They are not fact learning on that text. What they're simply doing is looking for patterns. So if diabetes and sugar are very oftentimes appear near each other, then the model learns that. And that's why it ultimately outputs that as part of the response. So that is ultimately a super high level way to look at why LLMs, quote, hallucinate in these cases. Despite the fact that responses that LLMs produce can really seem magical, as if the LLM itself is in a way reasoning and has a, quote, knowledge base, simply speaking, that LLM is just looking at language patterns. and producing language that it thinks is most correlated with your question. This is also oftentimes why when you ask a question of a large language model, it might not always return a comprehensive set of answers. So for example, in the case of find all of the clinical trials associated with Ozempic, the LLM might just return a couple of trials. It's not necessarily going to return all of them because, again, the large language model itself is not a reasoning engine. It does not go out there and search all of the clinical trials and try to find them for you. It merely looks at patterns that it's been trained on. So if it saw that Ozempic was typically associated with these types of numbers and NCT IDs, it will effectively generate those as a response. But it does not mean it actually goes out and pulls all of that information. So lastly, what approaches can you take in order to prevent and ultimately handle hallucinations? There's a couple of techniques that have evolved to help integrate knowledge bases and fact learning with the language power of generative AI. However, the one thing to note is that a lot of these solutions do require a technical know-how beyond prompt engineering. So what that means is that ultimately an out-of-the-box ChatGPT is likely not going to enable the accuracy that you're looking for depending on what your scenario is. A couple of common approaches, and I'm not going to dig into detail with them here, but feel free to comment or send me a LinkedIn DM if you have specific questions about these approaches. So a couple of these approaches include fine-tuning. And what fine-tuning effectively does is you feed this large language model more specific sets of text. And what it does is, again, it does not reason logically. It looks at that set you fed in that's more specific and finds patterns. So with diabetes example, let's say you fed sets of documents that talked about diabetes and environmental factors or genetic factors or obesity, etc. If the large language model learned those patterns, it might statistically generate a more accurate response. But fine-tuning in and of itself does not enable knowledge and fact learning, but it can help get the accuracy to be a little bit better when it comes to the end result. Another approach also includes leveraging fine-tuning with smaller models. So what that means is you can take a small model, for example, like a Llama 3, 8 billion parameters, and you can leverage fine-tuning with a larger set and train the model to be very specific, for example, at only identifying causes of diabetes. So if you give that model enough data and language patterns around diabetes being associated with environmental factors and genetics and obesity and poor diet, etc., that small model will become an expert at recognizing language patterns just on that topic, which thereby, as an outcome, increases the accuracy of the type of output that you would want. The third solution to build off of that would be to also create prompts that are a lot more targeted and to potentially pass in additional context to those prompts. So for example, when I'm asking the question of what is diabetes, maybe I pass it in a blog post that talks about diabetes, genetic factors, etc. And the LLM will be able to take that and interpret it with the context that you've passed in to generate, quote, a more accurate response. A fourth way to look at it is a concept of what are called RAG systems. RAG stands for Retrieval Augmented Generation. And effectively, what RAG systems do in combination with large language models is that you can plug into actual documents that you have, perhaps clinical trials or studies and publications on diabetes. And typically in these systems, when you ask the question, what is diabetes caused by? What these systems will do is they'll take that question, they'll actually search through the documents and try to find documents where some of the content relates to that question. And then generative AI will look at only those documents as part of its kind of context and generate a response that is tied to those documents. And oftentimes, this is where you start to see in certain chat tools references, right? So you might have a sentence generated that says diabetes is typically caused by environmental and genetic factors. Here's the one annotation, you click on the one and it shows you a PDF or a page, right? So that is more of what's called a RAG system. And kind of lastly, I'll throw this all under kind of this one bucket. Like, in order to truly enable, quote, accuracy or having appropriate references, it is likely that you're going to need a combination of different type of technical processing tools in a flow. So if you imagine a recipe has ingredients and steps to get to that ultimate outcome, in this case as well, you will, depending on the outcome, a set of ingredients where a large language model is one of them. RAG could be one of them. Other tech tools, SQL, databases, all of that can be all these different ingredients. And then you have to orchestrate a set of steps that effectively can do things like retrieve the right type of references, validate the outputs, and actually factually, quote, check them against different references, etc., to ultimately get you to the outcome that you desire. It's hard for me to describe what exactly a solution is here because it's so tailored depending on your use case. So there you have it, folks. Hopefully this was helpful in giving a high-level overview of hallucinations and how to think about them as you're thinking about implementing Gen AI into your workflows.